Good morning. Good morning. Happy Wednesday. Welcome to everyone that's joining us today. Glad to have you here. We have a lot of information today, content about data engineering process fundamentals. We'll be covering some information that perhaps some when it comes to data engineering you may not be familiar with. And if that's the case, then here's the content for you today. My name is Oscar Garcia. I'm a data engineer, software engineer. I deal with projects like this all the time. And so I'm really happy to share with you some of my past experiences. And I hope that this is something that you enjoy. And we'll get going. And welcome to everyone that can make it today. Really appreciate your time being here. And let's get going. So the first thing I do is ask a question, right? When it comes to data engineering, um, do you just do coding? Do you just do, for example, Python coding to do a data pipeline, or do you do low code utilities tools? Um, and if you do you set infrastructure or your software to run on, or do you even evaluate or design some of those concepts? Well, today that we are actually talking about that, right? So we go a little bit beyond coding and we start looking at the overall process, which personally speaking, I believe is part of the data engineering role, to be able to understand some of these um, uh, dependencies and infrastructure requirements for us to build our data solution. So let's start by talking about what data engineering is, and look at an overview. Data engineering really process a data engineering process involves several steps, right, for us to be able to get the solution in place. So we need to understand the problem statement, the scope of work. We need to work on the design, the architecture for creating the entire solution. So today, our focus will be more into the design and planning area of the data engineering process, and we'll talk about why is design and planning important. We'll touch details about system design and architecture, data pipeline and orchestration. Why do we use source control, and why do we really want to use things like continuous integration and continuous delivery? What is Docker containers and how that helps us? And what do we need for cloud infrastructure? How do we go about to building these things, right? So this touches on a lot of areas, not just coding data pipeline, but understanding how to design it, how to plan the architecture, how to automate the deployments, environment isolation, and things of that nature. I posted, you can see that link below it. All the code and reference to this presentation is found on this GitHub repo. I pasted the link on the chat. I added, in addition, I added a couple of another link for a book reference that we have. So you can take a look at and see if that's something that interests you. But let's continue. So why is design and planning important? Right, design and planning is crucial for building out the foundation of a scalable solution, right? What does that really mean? So what it means is that as we go through a discovery process and we understand requirements, we understand what needs to be built for the solution, we need to now transition into thinking how we're going to get that done, right? And as we start defining how we get that done, we also need to start thinking about what do we need in order for us to have that running and support it and maintain it and continue to grow it, right? So some of the foundational areas for design and planning really is, uh, how are we going to build this? Are we going to build this using a data pipeline? Do we need that? And if we do, how are we building the flows? What kind of coding language do we use? And what about the tools and data governance? Right, data governance is more about um, who can have access to certain areas of the system, who can look at certain data, who can control the flow of data and information, right? That's very important part of data engineering. We also look at designing the system architecture, right? So system architecture really is how are these cloud services are going to be used? How do they, the different flow points are going to connect and integrate with each other, right? How do we support this? What data platform do we use? So we start thinking about all those things, right? Because when we start thinking data pipeline and things like that, we start thinking, do we use a data lake? Do we use a data warehouse? Do we use just a database and so on? So this phase is so important because that is where you go into a war room with your team and you're actually talking about all this information, all these details, right? And on top of that, you start setting out some of the governance around it, right? So we need to talk about source control, right? What tools do we use for that? Do we use Bitbucket? Do we use GitHub? And do we use automation for the continuous integration and continuous delivery of the project? Meaning, as the development is going on, that we need to check in and build that and deploy it on a test environment for QA purposes. And how do we automate that? Um, Also, what is Docker container, right? And why do we need it, right? We use it for environment isolation, but what that does really mean, right? What is that telling us, and why do we need it? And also infrastructure automation with Terraform. What is infrastructure automation? What does that mean, right? If you're familiar with cloud or on-prem or on the cloud type infrastructure, you understand someone has to build some of this stuff. But how do we do that? How do we do that on a professional way and an automated way for us to keep a consistency, right? To have a machine going on and avoid any type of manual errors, right? And of course, we need to monitor and have recovery systems and things of that nature for us to support our solution. So all these areas are very important when it comes to the design and planning phase. Um, so let's now talk in detail about system design and architecture, right? So system design and architecture is really where we define the different technologies that should be used for that solution, right? So this is really where we start looking at it. Okay, so if we build this, what are we using? And this is not just really the coding language, right? Not just using, for example, Python or SQL, but also really understanding all the different areas that we're gonna need. And also with keeping in mind that it's important not only to think about how do we build the code, but actually how do we um, keep it safe, build it, and publish it to different environments, right? And what kind of libraries and utilities do we need to use to support some of our operational requirements? Operational requirements being, how do we monitor the system? How do we track that things are working properly, that there are not failures on the system? So the design outlines the technical solution, right? It includes the system architecture, the data integration, the flow orchestration, storage, data platforms, data processing tools, delivery, services that we're going to use, right? And the system architecture is that high level design that gives us lays out all the components and it shows the connectivity or the data flow between them. So we have workflow orchestration, storage transformation service, right? Continuous ingestion. So all this kind of the flow for the pipeline and in what systems are being used to do that. In this diagram, you can see that when it comes to this project, and if you follow this on GitHub, you will see that for us to achieve this, we use all these technologies, right? So we used Terraform, Docker, Prefect Cloud, DBT. Some of these tools may be something unknown to a lot of us, but just really a tool to get us to achieve something, right? So Prefect Cloud is great for monitoring and orchestration services. DBT is great for data transformation services, right? And things like that. And tools like Kafka and Spark that are great for data transformation and data streaming. So part of this, we need to talk about a data pipeline and orchestration. What is this, right? What do we really mean by that? Really, a data pipeline is just a workflow, right? That executes certain tasks, and this task, ideally, which the tasks are really some kind of code, right, that we're running and we're executing. Like, for example, calling an API to download a file or things of that nature. So we ideally want to run this on a Docker containers, right? And why? We'll talk about that in detail, but ideally we want to do that, right? And because we need, when it comes to data pipeline, we need to worry about the execution, the scheduling, the managing and monitoring of the pipeline to make sure that it's actually running, that's actually healthy, and that and there are no problems within the pipeline. That's usually referred to orchestration. So orchestration is a big element of operational requirements, and is the way to run things automated and not have manual processes around it. So, but how do we get this done, right? And we start thinking, how do we build? What do we need to build a pipeline? Obviously, what we do is we need to have a data source somewhere, right? So we need to talk about where is this data source coming from? How are we gonna consume it, and how are we gonna process it, and how do we process it, right? What kind of resources do we need? So, for example, we may need a VM for running our operations, our software. We need Lake, an orchestration platform to be able to kind of coordinate all this work, right? So all these things are very important, and we need to start thinking and choosing what kind of we start by choosing, okay, what coding language do we use, what kind of code repo do we use, what kind of cloud infrastructure do we use, is it Azure, is it Google, and so on, right? So the pipeline could be code-centric or low code approach, right? So that really depends on your team, right? On the abilities and expertise of your team. If you this more focused on a code-centric approach where we actually implement a lot of stuff, but you could definitely do a lot of things using a tool like Data Factory that basically through a low code interface type approach, you can actually create workflows, right? Or data pipelines and workflows. Definitely, we need to monitor the telemetry data, which is part of the orchestration and support and support activities. Docker Hub and Docker and GitHub for the continuous integration and delivery process to deploy our code, right? So our code has to be built from from the code repo into our VMs, for example, right? So how does that process? How do we do that? How do we achieve that in a way that is not manual? That's the key here. Scheduling, recovering from failures, looking at dashboards, right? All those things are very important. So we need to understand how we're going to support that and what kind of orchestration platform do we need to use for those purposes. Source control and continuous integration and delivery, right? They are vital for facilitating an agile development where developers, data engineers are constantly doing code changes, experiments, and they're deploying their code, and we need to kind of build that and automate the deployment of that so we can test it and validate that the changes are not going to break anything in production, right? This is important to enable for code change tracking to make sure you can revert back if there are problems for deployments. And for something that's really important, right? As you first deliver the solution, that's going to continue to grow. It's going to continue to be enhanced. So we need to support future changes, right? Bug fixes and deployments into new environments. So, and we want to have this automated. So, for example, we can use system Git, right? Git for source control. Definitely Git enables us to do source control, push the code to get so something like GitHub or Bitbucket, where we can actually now leverage those engines to do continuous integration, right? So in the continuous integration, we kind of build that, you push into a branch, and we automate the build for that. We run that unit test on top of it, or integration test, whatever kind of test we have, and we validate that it is working properly, or it gets rejected and sent back to the development team. And also continuous delivery, which is really where we actually now build that code. We push it out to an environment. We isolate that environment on perhaps Docker containers, and we publish that image that is ready for production quality type support. And we'll talk about, if you're not familiar with containers, we'll talk that in a little bit. Oh, right. Docker containers and Docker Hub. What is this for, right? So if you're familiar with a lot of this development tools, right? One of the biggest problems when you do your development is that the libraries are important, right? The version that you're developing with is key for deploying your software, right? Because if you just deploy the source code and you don't deploy your dependencies with the source code, then it may be a different version of .NET Core, a different version of Python, and some of the libraries you're using, maybe they're running on Python 3.9, but the environment has only Python 3.5. That's definitely gonna cause problems, right? So ideally, we want to create the environment definition and deploy all our dependencies and code within that, right? And that is really what Docker containers do for us. It will isolate that environment. It will enable us to deploy our code in it, deploy and build all of our dependencies in it, and we create a bubble. We isolate our environment, so we ensure that we're using the right version of .NET Core and whatever other libraries we're using, right? And Docker Hub is similar to, think of it as GitHub, for example, but in this case, is for Docker images. So when you have a Docker container and you build it, you create an image, and the image is that object that can be executed, right? That's like sort of your runtime, right? And that's why you push up to Docker Hub to have it ready when you need to do another deployment. So when you need to do another deployment to a VM, the VM, instead of you running, for example, a CI/CD pipeline or GitHub action, which is a workflow to build and test and deploy, you kind of pull it from Docker Hub, right? So you pull that image from Docker Hub and you download it to the VM, and now your code is isolated and deployed, and all this can be automated, of course. So containers ensures reliability and portability of all of our components, and Docker Hub serves that purpose, right? It's a registry to enable us to build those images. So ideally, most companies, what they do is they create images of their software and they push them to some kind of registry like Docker Hub to be able to manage their deployment that way. Okay, so but to get all this software, right? So we're coding, we're ready, we're in development mode, and we're doing all the stuff. But we need to start as a developer or data engineer. You need to kind of start building out the source. And I see a question here. I'll answer that right away. But let me. It's the question about Docker that I see right now. Yeah, so these are, so the question, the short version is, do you recommend adding Docker after you build the code? And what is the best way to implement it? So that's a very good question. It's very big. So in the development cycle, what you will do is you'll definitely start building your code, right? Your data pipeline, and you can run it locally. That's for sure. But then you need to go a step beyond that. And the next step is to do that. And by the way, everyone, just post those questions on Q&A. That way we can track it. The Q&A window automatically tracks it, and we can see it on the reports. So it's kind of like very good for traceability. But as you do your development, right, and you start building the code, and you run your through the CLI, through the command line, you run your code, you execute it, looks fine. But remember, this is running on your machine, right? And remember, when the statement, hey, it runs on my machine, right? That's not good enough, right? So we need to start building out in development mode and QA, of course, as well. We need to start building out infrastructure to test our stuff, right? To test our stuff. So, but to finish the Docker answer, the Docker answer is that you can do your code. Once you have your code, you identify all the resources that are going to go in your code. So you identify dependencies, like versions of what the language, right? Like Python version, what libraries you need, and all that. So only after you have that, you'll be able to implement your container, right? Because your Docker, the purpose of a Docker container, and we will look at a code later, is to actually list what files you need to copy over the container, what dependencies you need to build into that container. So that process is do your development, test locally, identify your dependencies. When you're ready, define your Docker file, which is used to build your Docker image. And then that's what you will use. Now, the question is, do you use Kubernetes or just Docker? So it really depends on infrastructure, right? So for example, a lot of cloud infrastructure would just let you build on a VM, download the Docker image, so you can run it and you have your environment isolation and all those things. That's great. That works great. So, but now it comes to scalability. How do we scale this, right? How do we actually if our pipeline or whatever application you're running demands another VM, how do we do that? Well, if it's just in the process that we're talking about right now, which is a simple one, we will run our Terraform scripts, which I'll go back to Terraform, and stand up another VM. And part of that build process is that we'll download immediately that Docker image, and then we automate that process. But then that is the process of running standing up a virtual machine, copying the image, and doing all of that. That will be the simple scalability approach for operational purposes. But you have products like Kubernetes. Kubernetes basically it automates all of this. You know, just like I said, right? It stands up a VM, stands up downloads the image, and it puts it into the cluster. So it's available for you for scalability purposes. And you're scaling out, you're setting up more machines. So Kubernetes is just another tool that does all of that for us, right? But of course, it requires additional knowledge, expertise, and so on. So, but yes, Kubernetes will be, that's the tool that's being used now for large enterprises. Okay, that answers that question. So, but what about, so I talked about, so how do we scale this out, right? How do we even deploy this? Not to go too far from first, we got to deploy. Then your development cycle, when you're dealing with cloud infrastructure, you probably, a lot of companies will set up a cloud environments for development purposes, and you build your infrastructure. So ideally, part of your development cycle is also to understand how you can automate the process to build form, because you want to recreate that, right? Yes, of course, there's specialists in a lot of companies will use specialists that will just build all these things for you. But it's a good practice for us to know this, right? As data engineers, software engineers, it's good solid foundation and understanding to do this. And remember that the goal of this presentation is to show fundamentals, everything around the data engineering process, and have understanding of that, right? So Terraform, and just like Terraform, and for example, a lot of the CLI, like Azure CLI, Google Cloud CLI, and all those tools enable you to do automation to build infrastructure. But specifically Terraform enables us to build consistency and reliability across environments. What that means is we create a piece of code, metadata, that tells us, I want to build this data lake, I want to build this VM with these settings in this region and this storage, right, and memories, and you create and you use that blueprint to cookie cut other environments, so you can actually now deploy in development and production and staging and production. And also if you need to scale, right, like Kubernetes will do to scale, then you need to build a second VM and a third VM and so on, right? And you can even scale them in different regions if you want to. But Terraform is a tool that uses a metadata type scripting that enables you to build the infrastructure and configure that as code. That's why they call it infrastructure as code, right? And the idea is that you can use this code just like you use the source code from a Python file or anything else, and you can automate it through a CI/CD, right? So you have continuous integration and delivery for source code for the solution, but also for infrastructure. So the same we can do with infrastructure. We can actually code it, run this CI/CD pipelines, and then you have a new virtual machine. You have a new cloud storage on a different region. You have a new data warehouse on a different region. And you have the flexibility that because maybe your data warehouse you're testing with doesn't require all the resources, then you scale down that version, right? And your staging, your QA, your development can have different configurations. But the idea is that you have this, you can automate this by having source code that we need to write. And we'll take a look at a Terraform example. But the idea is that Terraform, as you use the code, you have some kind of configuration and security configuration with the cloud environment that will give you a key to access the environment. So Terraform can be authenticated and authorized to build and issue and provision environments. It gives you the ability also to keep kind of governance, because it gives you the ability to track the changes, right? Like, for example, you can tell, oh, somebody changed a virtual machine. What was the last change? What did they do, right? So you have traceability when it comes to that. You also can track the state. So Terraform keeps the state data. So when you actually do and execute certain commands, and we'll see a little bit of that when we run the exercise, is that you will see the state of the environment. You will see how is the environment, when was deployed, and if you have changes on the Terraform file, then you will see what changes that is going to apply to the environment, which is very important to keep it to keep that kind of agile approach of building out infrastructure. So it's key. Okay, same can be done with CLI tools. CLI tools do that. The difference between Terraform and CLI tools is that a CLI tool, you have to download CLI tools for Azure, for AWS, for IBM, for Google. Terraform tries to be cross-platform, right? So the way it works is that you can run cross platform-specific scripts. So if you need to do, like, for example, blob storage for Azure, it may be the dependencies or reference will be a little bit different than perhaps the one in Google. But the thing is that the approach is the same. So the code is almost the same. It's just really saying, I use Azure environment for this case with this region, or a Google environment for this case, and so on. But it's meant to be to support multiple platforms, right? Which is great, because in real companies, they have failover systems from one cloud to the next. So you may be running AWS, but you want to fail over to Google Cloud to keep your production environments available. Okay. Right. So, all right. So, okay. So this is a reference on the things, on the areas that we talked about, some of the tools. Our next step is actually look at some code. But here, resources, there is a GitHub project, which I posted on the chat, and you can look at that where you have all this information. But let's take a look. Let's take a look at some code and see what we're, all the stuff we talked about. All right, so let me blow this up a little bit if it is too small. All right, so in the project, by the way, right, you will see it's supposed to be a real use case where we go through the entire journey for data engineering, right, from discovery all the way to analysis and data streaming. And in this case, we're talking about structure and design and planning, right? This is really what we are talking about today. But anyway, so you can use this. I use Visual Studio Code for this kind of stuff, and this is Visual Studio Code also. You can just clone that whole repo, and you can use Visual Studio Code to do this work. Okay, for the purpose of this presentation with the GitHub pages, as there is more documentation on it. So the first thing is, right, I kind of touch briefly on planning. What is planning? How do we do this, right? So planning is really that specific area where we're now saying, oh, we need to build this solution, and this is what we need as resources, right? So we start looking at planning, designing, system architecture, and all those things. So definitely one of the things we identify for this, to be able to support this project, we need to create a VM instance, right, to host our data pipelines in Orchestration. So this is really what was going to allow us to build out this solution to it and orchestrate the code, right? The details of building the pipeline will be in our next presentation, where we're actually doing a Python data pipeline with orchestration. But we need something to run this on, trying to focus on today. And we definitely need a data lake, because as part of our process, if you remember that diagram, our data source is a CSV batch process, right? So we want to grab the CSV or Parquet files and want to move them to a data lake, because that is sort of a staging transition environment to be able to grab that data, process that data, and send it into a data warehouse. So when we're building this cross-cloud platform solution, we're using Terra, right? And one of the requirements will be that we need a way for Terraform to be authenticated to access the cloud infrastructure and be able to deploy your virtual machine, right? And definitely this kind of stuff we're going to look at can be built through a GitHub action. If you're not familiar with GitHub action, it's really a workflow that gets automated through GitHub for you to do something, right? Whether it's running test scripts or building or deploying the files, right? In this case, deploying infrastructure. I just want to reinforce that, because a lot of people, they tend to be confused. Source code as opposed to infrastructure, right? This is just building out the infrastructure, the virtual machines, the cloud storage, and so on. So part of the requirements for this definitely is that to install Terraform, right? We won't go through the installation process, because we're going to run out of time. I just want to give you basically show you the process here, but you definitely need to install Terraform. This is instructed for Linux systems, and you actually go through it and understand it. So what's key here is that Terraform will run on a VM on your development environment, for example, when you're testing your development cloud infrastructure, or it will run on some other VM like GitHub, because GitHub, when it does an action, it will deploy to a VM, so you can run the pipeline, right? The deployment pipeline. So you will need to install Terraform, but Terraform needs to be authenticated with the cloud service, right? So you need to a service account on Azure, Google Cloud, whatever, but you need to provision a service account and give that service account the right permissions, right? So in this case, you need to, as part of the planning design, right? So what are the permissions for this service account? And how do we build the service account? Do we want to build one service account per resource? Or, for example, do we want a service account for building out BigQuery data warehouse? If you're not familiar with what BigQuery is, and the data lakes, the VMs, and so on. So that's part of the planning, right? Depending on the maturity level of your organization, you're definitely gonna have to think about all those things. But the point is, you need a service account. Once you have a service account, you need to assign some roles to it, right? And the role is to administer this. Can I build something, or am I just a viewer, right? So you have to work out the details of the roles for that service account. That's important. And depending on the details of the cloud configuration, you need to run enable certain APIs to be able to, because Terraform is going to call APIs to do this work, right? It's going to run on some VM, and it's going to call APIs to be able to provision these services behind the scenes. That's what's going to do, right? So in this case, you need to be able to enable these two permissions, these two APIs on Google Cloud, for example. So now, of course, we need to go through the process of how does this really work behind the scenes, and how does Terraform knows where the key is. So these instructions here will take you to the process of saying, this is how we authenticate. Look for this credential key on this particular directory, right? And all this really, it has to do more with operations and security, right? Where these keys are encrypted, and only a few people have access to these, only service account have access to these, and so on, right? So this just gives you the instructions on what is required for Terraform to be able to understand how it can run. But what is it going to run? What is it that it's actually doing? So let's take a look at the code and see. So when you go to this folder, you will see that there's a Terraform folder here, a GitHub, and a Docker. Take a look at that code, right? So the first thing for Terraform, the way it works really is that you need to define a variables file. And the variable files is key because it really gives of how do you want that file to that resource to be named, what kind of project key to have. So for example, a lot of systems will have a project key or a subscription, right, ID. So that really gives you that isolation at a subscription level to be able to build these resources, right? The storage class, the kind of level of data set one for building out the BigQuery data warehouse. So in this case here, we're defining resources for VMs, resources for data lake, and resources for a BigQuery, right? And we're just defining those variables. The purpose of that is when we go to the main script, right, and we go to script here, we can actually see that you know, we can start now the actual metadata JSON like scripting, right? Where we do what kind of version of Terraform we want, what kind of provider do we want. So a provider is Google provider. It could be AWS, it could be Azure, and so on. And we're actually defining our project, our region. In this case, we're using the variables, right? So you can see the variables, they are being picked up. So we get the project, the region, and all the definitions of for example, here's a data lake bucket we're trying to build here, blob storage, and we're defining the tier level for that, some of the rules, some of the expiration policies. Maybe we want this to expire at a certain time, 15 days, 30 days, 60 days, and that is the files, right? Those are the files that get deployed, and they have an expiration or archival policies, right? Same thing for data warehouse. What do we want to do? We want a BigQuery data warehouse. We want to build it in this region. We want a VM instance. We want this type of machine, right, and so on, right? So this is the actual code that gets executed through a GitHub, right? So you can manually do it, or you can execute it through a GitHub action, right? I meant to say. But anyways, what it actually does is once it provisions this, right? And this is cloud, by the way. Once it provisions this, right, you can go to your cloud store and look at the buckets that you have. And basically what we provision is this bucket here for our data source, our CSV files. And in the container, then this is where we're uploading. So as part of the pipeline, data pipeline process is that we're picking up these files and we're uploading these files into the data lake. So they are there for the data warehouse to process this file, right? And the way that will work is that if we look at our BigQuery instance, right, then you will see in our BigQuery, then you will see our BigQuery has this database called MTA data, which is really what it will do. It will just really look at this data lake, do the integration, and we'll look at that once with the data warehouse. There's a data warehouse session coming up, and it just shows how to grab all this data, all these files from the data lake, process them, and create the entire schema, right? So create a data warehouse start schema to support this process. But this gives you now the roadmap for building out your solution. Right now, you're getting to build this out. You're getting to see what's going to happen, how it's going to work, and so on. So this is very important. Now, when we go to, for example, a Docker file. So the thing is, once we build our code, how do we in Docker files, right? That's important. And the way we can do that is we can look at a Docker file, and this is at its very simple form. This is what it looks like, right? It actually gives us to pull this image. This is pulling an image with Python 3.9 and prefect, right? And prefect. And this is the image coming from GitHub, from Docker Hub, right? So we're using that as a source and copying our requirements, which our requirements will be those dependencies. So once you have your code written, you will have all the library dependencies and things like that listed on a requirements file. This is what you copy over to the container so you can install them when we run the installation command. Right, so we can run this, and just like you do through the CLI, you will just install all those dependencies. Now your environment has your dependencies. Now you can move your code, right? You move, you copy directory, you create directories for your code, and then you copy all of your data into that. And now you basically created a container that you can build to Docker Hub, right? So this is the entire cycle. So when it comes to Terraform build and GitHub action, the way that works is that if we look at the GitHub action, really what a GitHub really just another metadata looking format where you can actually do run a workflow with different steps, right? So for example, in this case, what this is showing us is saying, hey, run this job. The first step, you're on Ubuntu VM, right? Check out the repo into that VM, install our Terraform dependencies, initialize our Terraform dependencies, go to this folder, right? Because it's gonna copy all the files, and then it's gonna do what you will do manually. Initialize Terraform, apply Terraform, auto approve if you need to. Auto approve is really often not done, but for development purposes, you may do it. But it's really function environments is something you don't want to do, because once you're in production, you can't just auto approve just being monitored and approved, right? So you need to run an audit on that to be able to do that, right? So so going back here, and that's really the source code for this, right? So how you run it is where you gotta come in as developer, data here. You need to start looking at the process, right? So if you look at here, the way we run it through here is you can do the manual approach first, right? So you can get familiar with how to do that. So these are all the Docker examples. You have the documentation here that shows you the example, and then how to run it, right? So you go and run your GCP configuration, cloud configuration, you install your Terraform, and then you start, you can manually, log into Google Cloud, initialize your session, right? And then you can manually run Terraform, and then Terraform will start checking and say, okay, I can authenticate with the Google Cloud or Azure Cloud, and then you can do a plan, right? And a plan, what that means, says, hey, based on our Terraform files, give me a plan on what you're going to build, and it will tell you, hey, from this project subscription, I didn't find anything, so I'm going to do a plan on what it's about to build, right? And you can apply those changes, which means commit it and send in and deploy. Or optionally, for development cycles, you can destroy it to clean up your resources, right? So the Terraform lifecycle, the development lifecycle, is really this: you code it, you make your changes, you execute a plan to make sure that's what you want to build, and then you apply the changes if it's approved, right? And how you will do it manually, so you get familiar with it, so you understand how it works, and then you can start going into more of your automated approach. But ideally, in a real production environment, it will be always automated. It will run some kind of GitHub action, and it will give you that consistency of running and deploy. And here in this area, we're not showing how to deploy containers because we're not working on the data pipeline yet. We're just deploying the infrastructure. But on the next orchestration, step 3, orchestrate, you will see how the code is written. How is it put into Docker containers, and how those Docker containers are built into Docker Hub, so you can actually automate the deployment process. All right, so I think we made it to the end, guys. Thank you. Any questions? I'm looking at the Q&A to see if there are any questions. Let me know if you have any questions. Okay. All right. So if no questions, continue to play with the GitHub project. Give it a start, please. This keeps us motivated to continue this work. Also, take a look at this book if you're interested in the entire process, right? So this book basically takes us from a concept, a problem statement, and it teaches us the process of data engineering, right? How do we go about to do problem statements, analysis, and so on and so on. So you can take a look at that, and I hope you enjoy it. Guys, thank you for all of you guys for joining us, and I hope this is very useful to you guys. Please, we'll record, this is being recorded, so I'll send you guys a post event email. Please fill out the survey, and then take a look at the video, and please, thank you for your time. Okay, you guys have a great day. Thanks for coming in. All right, thank you guys. Bye bye.